we're going to start talking about differentiation rules. So we're going to go through a bunch of them here. It's going to be in two parts. So the first thing is the derivative of a constant. So what happens if I take the derivative of a number? So if f of x equals c, then the derivative df over dx is d dx of c, which is 0, right? So if I have a constant, I have a horizontal line, the slope of that horizontal line is 0. That kind of makes sense, right? So now we have our power rule, and this is most of the functions you've dealt with: x squared, x cubed, that kind of stuff, lines, 3x plus 1. So the power rule, if n is an element of the real, so it's a real number, then the derivative of x to the n equals n times the quantity x to the n minus 1. So what we're going to do is we're going to take our power, we're going to put it in front, and then we're going to subtract 1 from the power. Okay, that's our power rule. So here, our example 1, we have a bunch of different powers here. So I have x to the third. What I'm going to do is I'm going to bring that 3 down in front, and I'm going to go x to the 3 minus 1, or 3x squared. So the derivative of x cubed is going to be 3x squared. So I'm going to bring my power to the front and subtract 1 from the power. So this one becomes 2/3 x to the 2/3 minus 1, which is 2/3 x to the negative 1/3. Okay? I have the derivative of x to the square root of 2. So I have the square root of 2, x to the square root of 2 minus 1, and I'm done. Here I'm going to bring my negative 4/3 in front, so negative 4/3 x, I'm going to subtract 1, negative 4/3 minus 1, which is negative 4/3 x to the negative 7/3. Now this last one's a little bit trickier. So what I'm going to do is, if you remember, the square root is actually a half power. So what this does is it becomes x to the 1/2 times 2 plus pi, which is going to give me the derivative of dx of x. So half of 2 is 1 plus pi halves. Okay? So now when I take the derivative, I put this whole exponent in front, 1 plus pi halves times x, and now I have 1 plus pi halves minus 1, which is going to give me 1 plus pi halves times x to the pi halves. Okay, so there's my derivative. So anytime I have a power, I bring that power, I put it in front as a multiplier, and subtract 1 from the power. Derivative of a constant multiplier. So I don't care if there's a number multiplying my function. I'm going to take that constant, put it out front, and multiply it by the derivative. Okay, so in this example here, example 2, I have the derivative of 3x squared. So what's going to happen is I'm going to take that 3, put it out front, and I'm going to find the derivative of just x squared. Well, we know the derivative of x squared is 2, so this becomes 3 times 2x to the first, so this becomes 6x. So I'm going to take that constant multiplier, multiply it times my derivative. Okay? The derivative of sum or difference rule. So I don't really care if it's a sum or difference. What I'm going to do is I'm going to take the derivative of each individual part and go from there. So I'm going to take the derivative of u plus the derivative of v. So here, if I want to find y prime, I'm going to take the derivative of each individual part. So the first thing I have is the derivative of x cubed plus 4/3 times the derivative, because I just did the constant multiplier, x squared, minus 5 times the derivative of x plus the derivative of 1. Okay? Well, the derivative of x cubed becomes 3x squared, right? We know that because I'm bringing my power down, subtracting 1. Plus, now I'm going to bring my power down. So 4/3 times 2 is 8/3 x. 2 minus 1 is 1. So I have x. I bring my power down. So negative 5 times 1 is negative 5. And then I have x to the, remember there's an implied power of 1 here. So 1 minus 1 is 0. What is x to the 0th power? It is 1. So I actually have negative 5 times 1. I'm not going to write x to the 0th, so it just becomes negative 5. The derivative of a constant we said was 0. So here's my function, 3x squared plus 8/3 x minus 5. This is my derivative, okay? The derivative of a natural exponential function, so that's e to the x. So this one's nice. The derivative of e to the x equals e to the x. It's itself. So here I have the derivative of 5 e to the x. Well, the first thing I'm going to do is pull out that constant. 5 d dx e to the x. Well, the derivative of e to the x is e to the x, so 5 e to the x. Okay? So that's the first part on differentiation rules. We're going to talk about product rules and quotient rules next.